Well, today I'd like to talk about my favorite number, which is 2,184. So the story begins at Gathering for Gardner 11 when Alex Bellos gave a talk on the world's favorite number. And this got me thinking, why don't I have a favorite number? And what should that number be? So the first one I came up with was 130, because it has this neat property that it can be expressed in two different ways as the sum of a number and a power of that number. 2 plus 2 to the 7th, 5 plus 5 cubed. So 130 was my favorite number for one day. And then I discovered the even more amazing number, 2,184, which is the difference of a number and its power in two distinct ways. And here's my Gathering for Gardner 13 tie-in. So when you see something like this, you wonder, could this be a coincidence? And there is some precedence for this. Richard Guy famously said that there are not enough small numbers to do all the things we need them to. And so coincidences will happen. But to me, 2184 is not a small number. And so there must be some explanation for this, and I wanted to find it. Now, I'm not the first person to think about numbers of this form. Augustus de Morgan once had a famous puzzle. At one point in my life, the square of my age was the same as the year. What year was I born? Looks like we don't have enough information to answer the question, but if I tell you he wrote this in 1864, then you can solve it. You can just list the possibilities. If he was born in 1722, he would have had to be 140 years old when he wrote this. I don't think so. If he was born in 1892, he would have to go backwards in time, and he was not Doctor Who, so I don't think he did that. So the only possibility left was that he was born in 1806. So, of course, there's no reason we have to limit ourselves to squares, and so we can do this with other powers as well. And so I've listed the next few years where this trick would work, and in fact, you see 2184 showing up twice. This was noticed by Matt Parker, famous YouTube video star, who recorded a video on it called Why 1980 Was a Great Year to Be Born, but 2184 will be better. And there's a frame from the video of Matt celebrating his 45th birthday in the year 2025, which is 45 squared. All right, here are the 8 known solutions to our problem. So these are numbers that can be expressed in two different ways as a power minus the base of the power. And you notice 2184 on our list in red. And it's not even the biggest number on the list, but to me it is the most special because it's the only one where both powers are greater than 3, or greater than or equal to 3. So the other ones all have squares, which is a little bit easier. Okay. So now it gets tiresome to talk all the time about numbers of the form x to the a minus x. So I decided to start calling them absurd numbers. This comes from the Latin ab, which is to take away from, and surd, which is an old-fashioned word meaning the nth root. So absurd. Okay, and the number can be doubly absurd, it can be strictly absurd, and so our conjecture is that 2184 is the only number that's doubly strictly absurd. Okay, so a little bit of history. There's a surprising amount of history on this problem. So the simplest case is when the exponents are 3 and 2. This is solved in Mordell's book, Diophantine Equations. I don't know if he'd solved it earlier or not. There are two solutions. One of them is kind of trivial. The other is a little bit more interesting. And they're both in the list I gave you on the previous slide. To go farther into the history, I need to set up a table. So the first row of the table is Mordell's result. Second row, Ramanujan actually posed a conjecture which is equivalent to this problem for x equals 2 and b equals 2. And he conjectured that there are 3 solutions. And in 1948, Nagel proved him correct. And then Chris Skinner in 1989 improved this result to, in fact, resolving the question for all prime x and for the exponent b equals 2. And he showed that there are 5 solutions, which are all on the list I showed you. The amazing thing about this is that Skinner was a high school student at the time. So I'm very impressed by this, that a high school student could actually improve on a conjecture by Ramanujan. So I have some new things to add, so new results, mostly in the case where the exponent is 3. So unlike Skinner, I have to assume that y is prime, not x. And I also have to assume that the larger exponent is odd. And under those conditions, I can show that 2184 is the only solution. Obviously, I'd like to take away the assumption that a is odd. And I've proved it for a equals 4, 6, and 8, but I don't have a general proof for even numbers. I think it's quite hard. Also, I have some partial results for larger values of these smaller exponents, so up to 14. Again, there are a lot of side conditions, so there's lots of room for improving this result, and I hope that some number theorists out there will work on it. I'll just say 2 words about how we do this. Okay, so I use something called Mahadasu's theorem, which used to be called the Catalan conjecture, which says that the only consecutive numbers that are both powers are 8 and 9, 2 cubed and 3 squared. So the way I use this is I reduce our equation, which is down at the bottom in the 4th bullet point, to Catalan's equation, which is in the 2nd bullet point. That has only one solution, then I can work backwards to get the unique solution to our equation. So it's not a coincidence. Okay, my article came out 2 weeks ago in Integers magazine. It's online. I also have some copies with me if you want. And in the first line of this article, I give a shout out to Martin Gardner. So I was excited to be able to do that. And finally, let me just mention, this has nothing to do with the rest of my talk, but I have a book. I'm a freelance writer, have a book coming out in a month called The Book of Why, co-written by Udaya Pearl. We look at cause and effect in science, and it's a very important question, and I hope that you all get a copy of my book when it comes out. I've put a copy of the postcard in the gift bag. So, and more information is at my website, which is at the bottom of the slide there. Thank you.